Have you ever wondered how materials exchange mass, energy, or momentum at the boundary between two phases, like where a liquid meets a gas or a solid meets a fluid?
Welcome to this video where we are diving into a key concept of transport phenomena and chemical engineering, which is the interface flux.
You will eventually notice that tiny bubbles begin to appear along the inside of the glass. But why does this happen?
To understand any complex concept, we can look out for it in our day to day lives. For example, coffee making also involves mass transfer phenomena. To extract coffee from coffee beans, the concept of extraction is used.
So, this concept of interface flux is essential in understanding a wide range of processes, from absorbing oxygen into our lungs to the industrial application of distillation tower, which are used to separate different components. Now, let's see some of the examples in details.
Here we are looking at a very common industrial application of mass transfer, that is distillation column. So here is the figure of distillation still. In this, from the above there is reflux liquid that is coming, and from the below there is vapor which is coming from the reboiler, and there is interaction between these two phases. Now on the right side, there is the schematic representation of what is happening. If we look, the vapor are coming from the below, and there is reflux liquid which is coming from the above, and there is interaction in a plate. Between in this interaction, there is mass transfer occurring. The more volatile component is going with the vapor, and the less volatile component is getting transferred into the liquid phase, that is the liquid mixture. This is a very common example. This is used for purification also. Let us move to our next example.
So now we will see the example of oil recovery and transport. Now, we for that we need to understand the basics. The oil is trapped like 10,000 feet below the ground into some sedimentary porous rocks. The objective of oil recovery is to extract the maximum amount of oil which we can. For that, we use three methods, which are primary, secondary, and tertiary. The term uh, we are concerned here with the tertiary method, which is the enhanced oil recovery. You might have heard this enhanced oil recovery in our other subject of energy and environment. So, the basic objective now we need to address is that in the enhanced oil recovery, we need to extract the maximum amount of oil. So, for that, we will see some animation of how exactly the oil is drilled. So these are the drilling wells, and this dark brown layer is the oil, from which, from the above, we insert a pipe till the layer of the rocks where oil is present. The oil from this is, with the help of the pumps, it is extracted. Okay, and this oil is transported from long pipelines to the refinery center. Now, this oil pipeline consists of oil, gas, and water, both. Now, consider this that the water is a phase 1 with viscosity of U1 and the oil as a phase 2 of viscosity of U2. Now, the basic question here arises that both of these are fluids. Then, how come this is an interface flux? Correct?
Yeah, exactly. And here lies a very key concept of transport phenomena, that is the concept of phases. Till now, what we have learned about phases is mostly it depends on intermolecular forces. So basically, we have learned about three phases, that is solid, liquid, and gases. And that is defined according to the intermolecular forces between the molecules. The molecules, if the IMF is very low, then it is gas, and if it is very strong, then it is solid. But in transport phenomena, the transport property is defined whether the phases, whether we should treat the phases as different or similar. So in this case, Even if the fluids are in the same state, according to our previous definition of IMF, that is, the molecular forces are almost in the same range and both are liquid, but their viscosities are different. Since the viscosities are different, momentum transfer, in momentum transfer, what is the deciding factor? That is viscosity. Viscosity is different, that is, the transport property is different. Therefore, we will treat both the fluids as different phases. Hence, this is an example of interface. Yeah, this is a very earlier I got confused between these two terms. What is interface and what is interface?
Okay, so let me help you with that. So basically, these both terms can be simplified in a very grammatical manner. Interface is a noun, while interface, which is the first one, is an adjective. Okay, so interface, FACE, is basically the geometrical term between the two phases. It is the boundary separating the two phases, while interface is the term which we use to define a system where there is an involvement of multiple phases. Now, we will have a preview of what we are going to cover in the further video.